What is a sound wave and how do we hear it? Imagine a ripple spreading across a pond after you toss in a stone. That's similar to how sound travels through the air or water. A sound wave is a type of mechanical vibration that moves through a medium like air, water, or solid materials. These waves are made up of regions where particles are squeezed together tightly, called compressions, and regions where particles are spread apart, called rarefactions. Together, these alternating high and low pressure areas create what we call sound waves. They carry energy from a vibrating source outward, like a guitar string vibrating when plucked or a person's voice when speaking. Sound waves are longitudinal waves, meaning the particles in the medium vibrate back and forth in the same direction the wave moves. The range of sounds humans can hear spans from about 20 Hz, which is very low-pitched sounds like thunder, up to 20,000 Hz, which are very high-pitched sounds like a dog whistle. When an object vibrates, it disturbs the surrounding medium, creating these pressure waves that travel outward. For example, when a guitar string is plucked, it vibrates and compresses the air around it, producing sound waves that travel through the air to reach our ears. Now, how do we actually hear these sound waves? When sound waves reach the outer part of our ear, called the pinna, they are funneled into the ear canal toward the eardrum, which is a thin membrane that vibrates in response to the pressure changes. These vibrations are then passed to three tiny bones in the middle ear, the malleus, incus, and stapes, which act like a lever system to amplify the vibrations. The amplified vibrations then reach the cochlea in the inner ear, a spiral-shaped, fluid-filled structure lined with tiny hair cells. These hair cells bend in response to the fluid movement caused by the vibrations, converting the mechanical energy into electrical signals. These signals are then sent via the auditory nerve to the brain, where they are interpreted as recognizable sounds like speech, music, or environmental noises. Understanding this process highlights how important each part of the ear is for hearing. If any part of this pathway is damaged, such as from loud noise exposure, infections, aging, or injury, it can lead to hearing loss. For example, loud noises can damage the hair cells in the cochlea, which do not regenerate, leading to permanent hearing impairment. Protecting your ears from excessive noise and seeking medical advice if you notice changes in hearing are key steps in maintaining hearing health. Recognizing that sound waves are physical vibrations that our bodies are designed to detect helps us appreciate the complexity of hearing and the importance of caring for this vital sense. Always consult healthcare professionals if you experience hearing difficulties, as early intervention can help preserve your hearing and improve quality of life.